Good morning students, I am Vetri Chelvi from Vetri and Vetri NEET Chemistry. Today I am going to give the question to the topic of solution. Before going to the topic, I request the viewers, those who are yet to be subscribed, please subscribe my channel Vetri and Vetri NEET Chemistry. If the viewers are new to my channel means I am requesting the fresh viewers also to subscribe Vetri and Vetri NEET Chemistry. Your subscription will be motivating me, which brings a lot of energy in form of questions to you. Let us go to the topic. The topic is to solution and the question is NEET 2013. How many grams of corn nitric acid solution should be used to prepare 250 ml of 2m nitric acid? The concentrated acid is 70% of nitric acid. Okay, now let us first understand the problem what is given. You are provided with the concentrated acid of 70% of nitric acid. What is it understood? 70 grams of nitric acid present in 100 grams of water. This is the meaning of 70% of nitric acid. From this we have to dilute or prepare the solution which is having volume of 250 ml and its concentration is 2.0 molarity. To prepare this solution how much I have to take to dilute to make it? So this is our question. So we have to divide this problem sum as a two category. First we have to find out how much of nitric acid present in this solution. The solution volume is available, molarity is available. From that, find out the weight of nitric acid in this solution. And then we have to come for the calculation to get the weight what we should do. So now I am going to the first part of the problem. This is the formula is molarity is equal to given weight by molar mass volume ml in 2000. This is the formula. The molarity of the solution is, I am substituting the value, molarity is 2.0. So that is equal to weight of nitric acid, the question, divided by molecular mass of nitric acid 63. Here important point is you should take only the nitric acid molecular mass, don't by mistake as a water, because water is a solvent, solute is the nitric acid. Then volume of the ml is 250 ml. Okay, 250 ml and here formula is 1000. Okay, here to find out the molar mass of the nitric acid, you should know the value by heart. Even though if you don't know, please take this one. This hydrogen 1, nitrogen 14 and oxygen is atomic weight 16 into 3, 48. On addition, it should get the 63. For so many important chemicals, you should know the molar mass, which is much helpful for the examination hall. So now you have to, from this calculation, you have to find out the W. That is the weight of nitric acid. Now here of course I am writing W is equal to cross multiply. This is 2 into 63 divided by the 4 and this is on cancelling. You are getting W is equal to 63 by 2. Just you keep it in the mind, just because we have to bring and substitute on other formula. So with that level you can keep it. So what is this? Is weight of nitric acid we have to calculate it. So we required 63.2 gram of nitric acid to prepare this solution. This is the information. So how much gram of this solution I have to take and dilute, that we are going to do as a statement. That is 70% indicate, already I told, 70 gram of nitric acid given from 100 gram of the nitric acid solution. That means that level it is diluted. So 70 gram of nitric acid you can get from 100 gram of the solution. Therefore 1 gram of nitric acid you can get from. So this is the to get 1 gram. What is the weight of nitric acid in your hand? Therefore 63.2 gram of nitric acid we can get from how much of this solution. So this one this is what 1. This is the weight required. So into 63 divided by 2. Now this is simple calculation. 0 and 0 getting cancelled. 7 into 63, 9 is getting cancelled. 2 with the 10, 5. So 9 into 5. So 45 grams of that solution should be taken for dilution. So this is your answer. Let us go and see. 45 grams of concentrated nitric acid is the answer. Okay children, you are selecting. So now very important point. First understand this problem. This area you have to focus on how to analyze the sum and differentiate the formula. Once you understood remaining part is very easy. Let us go to the next question. Okay children, this question is having, you can see, it came on 2 years, that is 2011 and following the 4th year 2015. So we can expect the same question for 2020 in, let us complete first question. What is the mole fraction of the solute in a 1 m of aqueous solution? Okay, let me write what are the questions they are asking is. First they are asking what is the mole fraction of solute. Now let us put the diagram. Here some solute you are adding. Solute only they are giving. So they are not giving anything else. So that is you take it as a XB. It is the mole fraction. Now what is here is aqueous solution is given. What is it? 1.00 molality of aqueous solution means it is the water is the solvent. So that one I am writing as the what is the solvent. So water is the solvent means you can take it as a. So what they are asking is mole fraction of solid. So here I am putting the question mark. Question is mole fraction of solid. Now let us write the first formula. Mole fraction of the usually A for solvent, B for solid. So we are writing solid. XB is the mole fraction of solute is equal to number of moles of the B divided by total number. Total number means number of moles of the water plus number of moles of the solid. Now our work is to find out the number of moles of A and number of moles of B. Now I am putting here how we can find out the number of moles of your water solvent. Okay, what is the number of moles to find out mean? That is given weight by molar mass. What is the weight you are provided is, now this is 1 molality means what is it? That amount of solute dissolved in it is understood dissolved in 1 kilogram of water. 1 kilogram of water which is equal to 1000 gram. So this is given weight. Now I am writing 18 is the molar mass of your water. So this on added division it gives 55.55. This is the very important data each student should know. What is how they have to register in the mind. How many moles of water in 1 liter is equal to 55.55. This is by heart they should know. This is for understanding I am giving. Given weight is the 1 liter of water, 1 kilogram of water, that is 1000 gram divided by 18. This is 1000 gram, this is 18 gram per mole. Gram getting cancelled and you are getting the unit of mole. So this data should be in your mind. Okay, anyhow let us go to the now next work is what is NB. Same formula is there. So what is the given weight? Number of moles equal to what is this is given is mole. This is one. Okay. Now here formula is they are given as a small m molarity. So molarity is equal to number of moles divided by the weight of solution in the kilogram. Okay. Now substitute the values. What is molarity is 1. What is the unit is? It is mole per kg is equal to, that is equal to number of moles we have to calculate. You take it as a question and how much it is per kilogram. 1 kilogram of water. Okay. Now here n is equal to bring here that is 1 mole per kilogram into 1 kilogram. So kilogram getting cancelled. Your answer is 1 mole. So what is understood is number of moles of the solute. What is it called as a 1 m, that is 1 m, 1 molarity. Here it is given is called it as a 1 mole. That is what I want to say is if it is 1 mole, it is understood what is it called as a number of mole is equal to 1. So this knowledge should be in your mind. Now let us, this should be in your mind, this should be in your mind by a glance. Okay, now let us go to our final work is xb is equal to, right, nb. So what is nb is, this is, it is written here, 1 divided by, what is na plus, that is 55.55 plus 1. So we can write as a 56.55, that is equal to 1 by 56. I am writing as a 57, and both 100 multiplied by both numerator and denominator, and this is for simplification. Yes, this 100 is become here 10 power minus 2. So now this is on approximation. At the end you go for approximation. 57 I am taking as a 60. Okay, now it is getting cancelled. It is 2, 3. Here it is 5. So 5 divided by 3, you are getting 1.66 into 10 power minus 2. So your answer is 0.0166, mean on round up you are getting 7. So now go and verify the answer. Here you are getting, of course. Now this is the way you have to approach the sum. Before going to the concluded, sometime they already I told this question we can expect 2020. Instead of the solute they can ask solvent also. If it is solvent, mean the solute you got it here as a 0.017. If they are asking solvent, mean you subtract this one from 1, because binary solution total mole fraction is 1. So 1 minus this equal to mole fraction of solvent. So before answer, double check your question and answer it. Now we are moving to the last question, which is a very important easy question. All India 14. Okay. Of the following 1.1 m aqueous solution, which one will exhibit the largest freezing point depression? Let me write first formula. Delta TF. This is the, what is it called it as a, what is it called it as a, it is the, what is this one is the depression in the, this is the depression in the aluminum sulfate. Now let us see the question. KCl, glucose, aluminum sulfate, potassium sulfate. The formula is delta TF is equal to I into KF into M, of course. Here what are the things are same in here? For all the solution, the concentration is given. What is it? 0.1. So all the solution, this is common and this is common. What they are asking is which among the solution having greater delta TF value. This is the question. So this one depends upon I. What is I is the number of ion. So now let me write I for each one. For A, I is equal to 1 plus 1, 2. For B, I is equal to 0 because it is non-electrolyte. For C, I is equal to 2 plus 3. Aluminum sulfate, 2 plus 3. 5. For the D, I is equal to 2 plus 1, 3. So what is this indicate? So I value is increases, delta TF value also increases. So now which is having the, they are asking the largest delta freezing point depression only. So they are asking the difference only, which is having greater difference. So more I, more different. Who is having more I is there? This is the 5. C is the more I. So I am putting this one. Okay, children. Now this is according to the question. Of course, more I, more different you can find out. Some other angle they will ask the question. For that I am giving the one more tip is for this line diagram I am putting for freezing point. It is 0 mean that is your water. I am writing as a T0. So any solution it is decreases. That means for example I am writing it is minus 2 mean that is called it as a freezing point of this is both a freezing point of the particular solution. So let us have this is for where this is for when I is equal to 2, you are having this line mean when I is equal to 5, that is the value is greater. What we are telling, value is greater mean delta TF also greater. Let us write the diagram, same diagram. Say because the water is the T0, this is your 0. Now the I is greater mean this is greater, you give biggest difference. So now it is T. Now this different, now it may be a minus 5. So now this is the, what is the difference is greater. I is increases, the gap is increases. From that we can identify. Prepare well children. Thank you students.